Welcome back, guys. So we had completed our schematic in Proteus. Now it's time to write the code in Arduino so that we can upload the code in our controller and we can run. So what we will do, we will open Arduino App. So here is my Arduino application. We have predefined function, one for setup and one for the loop. So what we will do, we will first save this. And the next thing what we are going to do is we will start writing the code. Sensor has defined echo in 6 has defined trigger pin. Let's not give the pin name as of now. I thought of giving pin 6 and 7, but yeah, let's skip that part. So now sensor pin has been defined. Now it's time to define the pins for the motor. So let me add the comments pins for motor. So we have, as we know, we have 4 pins to control clockwise and anti-clockwise direction. There are around 2 motors and we need to control those. Let me add has defined for them as well. Has defined forward rotation. Let me give as left motor. Later on we will assign the pin because we need to go back and check the schematic or giving the number of the pin. So as of now I am just giving the name for these pins. So now let's so we had defined the pins for the sensor and for the motor driver. So now it's time to go back to the schematic to see the pin allocation. So for this we had connected echo pin to 6. So let's give that as pin 6, and we had given trigger pin to 6. So trigger pin should be 6 and echo pin should be 7. So echo pin is 7. Now for motor, so we need to check. So pin 2, 3 for clockwise and anti-clockwise for the left motor, and pin 4 and 5 for clockwise and anti-clockwise direction of right motor. So let's give the name respectively 2 and 3 for the left motor, backward and forward, and for right motor it is pin 4 and 5 for backward and forward direction. So this is the pin allocation for the motor. Now we need to give the pin number for liquid crystal display, that is nothing but our LCD. So let me comment that and understanding right as pins for LCD display, and before doing that we need to import the library for the LCD display. So let me add that as well. Include liquid crystal.h. LCD, and let's allocate the pin for those. So and 13 goes to reset and enable. What I will do, I will arrange this properly. So instead of 13 I will mention 12, I will mention as 13, and this let me make it as 12 so that it will be in proper order. So 13, 12, and then 11, 10, 8, 9, 8, and let me give the name that way itself. So 8, 9, 10, and 11. So here I need to write it in a reverse order because these pins are in reverse. So let me write it as 11, 10, 8, and 9. That's how it is. It should start from 8, 9, 10, and 11. Let's end this line, add few of the variables so that I can store the data for the duration first, which is used for the sensor, and next is for distance, again for the sensor to calculate the distance. So that should be in a decimal form because that's a high value. So let me place that as a long duration, semicolon, then integer distance. That's all for the variable side. So let me move it above, set that as a pin input or output. So let's start from above. Pin mode echo pin, comma that as output. End of the line. I don't want to type again and again, so instead I will paste it and I will just rename those. Trigger pin, copy, that should be as an output as well. All of these pins are the output. Copy and replace it over here. So one more left out. Copy this as well. I think something I had missed this one. Let me copy paste over here, and this one as well. So let me place it over here. So now all the pins has been set up. Now it's time to write our main code in the loop. So it's time to write the main loop. So first we will write the code for our sensors, since it is continuously sending some trigger value and it will receive the echo so that it can analyze the distance for that. So let's write the code for that. Initially I will use this function for trigger pin to be initially 0. So I will write as digital write trigger pin as low, end of the semicolon. Let me add a delay So what I will do is I will add a micro delay. So for that I can use a function that is delay micro seconds to, it basically says it is 2 microsecond delay. Now it's time to set the trigger pin high for 10 milliseconds. So initially it will be low for 2 milliseconds and then it will be high for 10 milliseconds. Copy paste the above line itself, paste it over here. I will make this as high. I will make this 10 microsecond, and again this pin should go low. Copy this line again and I will put it over here. We are gonna receive via echo, so and that value should be stored in this variable duration, because echo. So let me type this as duration equals, I will use the function of pulsing. So whenever it is high, so it will collect those data using the duration. But here is the catch. Actually I had made one mistake. Any guesses? Yes, exactly. This pin should be input pin, not the output pin. So let me correct this. So in the setup I had updated this as an input so that now it can receive the data properly. Now next thing what we require is, what I'm gonna do is I need to calculate that as a distance. So I will add that in a variable distance. Distance equals duration of the data what I have received, duration into 0.034 divided by 2. How I got this formula I'm not going to explain. You have to research and you have to drop that in a comment box. So now it's time to display this data on our LCD display. So I will type that as LCD display. First we need to set the cursor. LCD set cursor 0, 0. LCD dot print distance now. I'm not gonna type this again. So we had done with the sensor part. Now it's time to use this data to control our motor. For example, if the distance is too low, then our motor should run in the backward direction, then it should move right and it should move away from the obstacle. So let's write code for that. So simple if else condition we will write. So if the distance is greater than or equal to 500, then digital write in a, say, backward direction when it detects the obstacle. We will write the code for that. Backward, rotate. Similarly, I will copy this as well. It will rotate the motor in the opposite direction. So rotate in opposite direction. Let me add this comment above so that it will be understood. Okay, now after rotating few steps backward, it should rotate on the right hand side or the left hand side and then start moving. So I will add the code for that as well. So after moving back, it will move left, or you can write the code for moving in right as well. So it's up to you. Direction. So let me add a small delay. So let's add a delay of, say, 1 second, or 1 second. It will rotate backward, and here this will run again for 1 second. Okay, now I will add one more else condition so that it will run in default in a forward direction. Just I will copy the whole line. So whenever it doesn't detect any obstacle, the backward direction pin should be low and the forward pin should be high. So I will make this as high. Let me add this comment as well. Forward. Okay, so I will add display as well, so you can see where the direction is, what the direction it is moving. For this I will add say over here. Let me keep this as 0 and 1 stand for the next line, and it should be moving back and here moving left. And before that, let me clear the screen, so I will add cd clear function. Similarly, I will add for the forward as well. So this is our entire code. I had wrote entire code in front of you, so you can have a better understanding of the code, how to write it, and I will add this code in a description so that you can have access and you can use it, because a lot of people had request for the code in the previous video. Now it's time to compile our code. So what I will do, I will export that in a binary so that I can import directly in Proteus. You need to go in the sketch and click on export compiled binary. So it started compiling, and meanwhile it will also convert that in a binary, that is .hex file. So now compilation has been done. I hope this has generated a hex file as well. So let's go show sketch folder. Okay, so what I can see, it has generated a standard hex file. So let's go directly to the Proteus now. Double click on Arduino. You will get this edit component window. Here in program file, get the path. Now you need to go in the folder where you had stored. Okay, the code is ready. Now it's time to run. So here bottom below, click on run. Okay, I see a fatal error. Let's see. Okay, there is one log issue. It says ultrasonic sensor hex file is missing. So we need to add the hex file for this as well. So you can find this when you had downloaded. I see it has already been there. But anyways, I will add that as well. Hex file has been added. Click on OK. Now let's run this. Okay, seems like there is some mistake. The LCD is not showing up anything. Okay, the power supply has been missed out. So let me add the power supply for this, and also the ground. Let's run this and see this time it should work. Okay, something wrong over here. Go back to the code again and see. Let's debug this issue. Okay, so I think I haven't added the begin. Let me try to add a begin in the setup. Begin 16, 2. Okay, let me compile this again. Now I will go back again to Proteus. I need to import this code again. Click on OK. Let's run and see. Okay, so basically I need to add the function in the setup only, then it will show up. So now it is working properly. Okay, it had cleared the screen. This is one more issue. Let's figure this out, how we can resolve this. So how we gonna resolve this? So every time it goes back out. So let's go back to the code again, and we need to figure this out. Why it is going blank. So let's copy this and let's paste this over here. Done. Let's go back to Proteus again. Yes, now it works fine. Now you can see, guys, when the distance is less than 500, both the motors are rotating in clockwise direction, and also it is displaying moving forward. As soon as I create an obstacle or I increase the distance using this potentiometer, yes, you can see it started moving in opposite direction first, and then one will rotate in clockwise, another will rotate in anti-clockwise. So it is now moving backward. I see there is one more issue over here. It stops instead of rotating. Let's debug this as well. Now let's go back to the code. You see what's happening over here. Okay, now let's see if it works or not. So let's save this. Let's go back again and we'll compile this code and see whether it is working or not. Yes, so this is how it is, guys. The output we were expecting. So as soon as it detects obstacle, it should rotate, and then one should rotate in clockwise, another should rotate in anti-clockwise. So when the value is less than 500, both the motor will rotate in forward, in clockwise direction, as you can see, and we will get a message saying that moving forward. Now when the distance or the obstacle is detected, so I will do that by increasing the potentiometer value. When the distance is above 500, the first the robot will move backward, and then it will move to left, so that one will rotate in clockwise direction, another one will rotate in anti-clockwise direction. So both are rotating in opposite direction. Now it is moving left, so one is rotating clockwise, another one is rotating anti-clockwise. So that's all for today's video, guys. If you like the video, click on the like button, do subscribe my channel, and do comment your suggestion for the next project.